Hello world and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, Architect Winelect, and today we're going to be looking at the landscape of IoT on Azure. We're going to be looking at this from the perspective of architecture and then see how Azure fills in the gaps on that. So I wanted to camp out on this slide for a while. This is really going to try to lay out on a single slide all the things that are going to be involved with the IoT landscape on Azure. So of course, everything in the IoT space starts with the things. Now, when you talk to people about IoT, this is probably what they're going to be most familiar with because it's probably what most people have exposure to. So if I say Internet of Things, people probably think about Nest doorbells or Simply Safe appliances or different kinds of things that you can use in your house that make your house quote unquote smart. And all of those things are part of an IoT network. So that's very familiar to most people. And that is true. It is the sensors, it's everything that goes into making a device work. And on Azure, there's a couple of things that you can use to create these things with. One is Azure Sphere, which is like a lightweight operating system that you can put on a device. And you can use this as an embedded system that will allow you to create devices and then have those connect back up to Azure and also secure the device using that particular specialized operating system. There's also the Azure IoT SDK, which is a specialized SDK for interacting with some of these other services that we're going to be looking at here in just a second, but it can be embedded on many different systems and supports a lot of different kinds of languages as well. So related to the things side of the Internet of Things, you also have the IoT Stack that typically exists on many different IoT deployments. And in Azure, there's a lot of different services that fulfill this. Basically, with the IoT Stack, you're going to be managing devices and also brokering messages between devices and the cloud. So this is a management suite that allows you to scale devices, and it provides a lot of services for that. So you can provision devices, you can take devices offline, it provides security for devices. It also provides a messaging infrastructure so that you can send commands to devices and also receive telemetry back from devices. So all of these endpoints and all of this management infrastructure is encapsulated in a couple of different services on Azure. IoT Central, which is more a software as a service offering that encapsulates a lot of the functionality you're going to see in some of the more low-level ones, but it basically is the ability to create what we call applications in the context of an IoT Central, and that allows you to have multi-tenancy with different devices so that you can then scale not only the devices, but also the downstream components of things that are going to be integrating with whatever those devices are serving up. Then there's also IoT Hub, which is kind of the more general purpose tool on Azure for managing devices. So it has all of the device provisioning services that you need for scaling up devices, for putting certificates on devices, generating those certificates, for messaging from a device, for messaging to a device, and all of that kind of stuff that is kind of more low level and more functionally oriented, while IoT Central is more app or software as a service oriented, while abstracting away some of those details that IoT Hub does. And then, of course, there is the Azure Digital Twins. Azure Digital Twinning is basically the ability to manage device configuration in a suite of software, and it will integrate with Azure IoT Central or IoT Hub. And that basically just maintains some kind of state information about devices in the cloud. And so if something was to lose its configuration on a device, or you need to make a change to a device, you can synchronize that twinning information back down to the device and vice versa, back from the device up to the twin, so that you can have that consistent configuration. And you don't have to go to the device every time you need to get information about a device. You can go to twinning information and you get the same information about a device. Now, the next three things I'm going to be talking about are data related. And these are three parallel paths that do similar things, but they do it in different kinds of intervals. And these are hot path, cold path, and warm path. And we're going to talk about the nuances between these two. And then we're going to look at the Azure offerings that support these. Now, what happens with things in the Internet of Things is they will have some kind of telemetry that they need to send up to the cloud, or there's some kind of event that they needed to notify something on the cloud with, whatever it might be. What you end up with is something originating over here in the things side And that is encapsulated as a message and then sent over here to the cloud side. And that's typically going to be picked up by Azure IoT Hub on Azure, or whatever is obfuscated by something like IoT Central. And then what ends up happening with that data is it is routed to one of those three different paths that we talked about in the data workflows. In this case, we're talking about the hot path, or the cold path, or the warm path. Now, hot path data is data that is processed in real time. So as it comes off of the IoT hub or whatever obfuscations on top of that, it gets processed within seconds of that happening. So the message hits the hot path, it's processed, and then it's presented to something in the consumption layer. Now, we'll talk about that in just a moment. But the consumption layer is basically going to be able to consume that data immediately once it's been processed in the hot path. Now, the consumption layer doesn't mean that it's going to be consuming the latest, hottest data that's coming off the wire. It just means that it's available at that point in time. So that's really what we're getting about with hot path. So you could write the output from a hot path to a cold storage system that is consumed by something like an API. The data is written in real time, but the API might be querying that data that was written an hour ago. The main thing that you're taking away from hot path is that you're processing data in real time as it's happening. However, what's consuming that might be querying old data that was processed an hour ago, or it could be something that's processing it and then presenting it in real time, such as a dashboard that is constantly monitoring things in their present state as it comes off of the hot path and into the consumption layer. There are several offerings on Azure that do different kinds of processing on Azure. Now, probably the one that you're going to be using the most for hot path data is going to be Event Hubs. And that's basically the messaging platform that is purpose built for this. Now, Event Hubs can also write messages to a cold storage that can be consumed by cold paths or warm path. But whatever you get out of Event Hubs can be wired up to all of these other kinds of processors, such as Stream Analytics, which is a platform as a service offering that uses SQL to transform data, aggregate data, enrich it, whatever it might be. And then you can have functions, which can be triggered by Event Hubs. And that's basically your code. So you can do whatever you want to in that context. Then there's Azure Synapse, which Synapse allows you to have a whole suite of tools at your disposal that do all kinds of things related to data processing. And it'll show up a couple of other times in this. And one of the things you can do with that is streams. And then you can also use Kafka, which is out of the Apache space, which is similar to Stream Analytics in that you do real-time data processing, but it's more specific in its implementation, but it wires up directly to Event Hubs. And of course, Databricks. Databricks is typically used for more batch style oriented workloads, but you can use it for streaming as well because it is a Swiss Army knife for data processing in the way that Synapse is. So combined, any number of these can do a lot of different kinds of hot path aggregations, transformations, queries, filters, whatever it might be. They're all different tools that all do a very similar functionality within the Azure context. Now, I want to talk about cold path next because it's kind of the other extreme from hot path. Hot path is more real time and it's more event driven than cold path is. Cold path is more batch oriented. Hot path will process the message as it hits the system, while cold path really processes the messages as they accumulate on the system. And rather than being triggered by the message itself, what it allows for is data to be accumulated over a period of time. And then typically on a trigger that is timer based, it will then take whatever data has been accumulated and process that data in batch. And then it will write the data back to some kind of cold storage, whatever the processing on that data might look like. Now, the way that this typically works as opposed to hot path where you have something like Event Hubs that deliver a message to a processor, what you typically do in this case is you land the message that as it comes off of IoT Hub into some kind of what we call cold storage. So that's typically some kind of database or some kind of data retention system. Now, that could be something like a data lake, which would be basically built on top of blob storage. You can also do it with blob storage as well, but fundamentally, data lake is built on top of blob storage in any case. Or you could do it into some kind of Azure database as a service offering. So you could use SQL databases for this. You could use Cosmos databases. You could use Postgres or MySQL, whatever it may be. You're basically just putting it into some kind of data storage platform. And then from there, once it's accumulated in that cold storage, then the trigger fires and it's going to launch whatever processing capability is going to be a part of that. And that's where something like Data Factory or Azure Synapse or Databricks is going to come into play. Now, Data Factory is software as a service or platform as a service, depending on who you ask. But basically, it gives you the ability to visually build workflows inside of Data Factory that can then take data out of a data lake or database and process it in batches and then write the results back to some kind of output. Now, Synapse has similar functionality, but it is integrated with the Synapse suite on Azure so that you can use it as part of a full suite of tools rather than having a bunch of tools like what you would get with, say, if you use Data Factory, Data Lake with Stream Analytics and Event Hub. Synapse just kind of combines a lot of things and offers it as a single offering with a set of tools within that offering. Then you can also use Databricks, which is going to give you the ability to write code to process your data. And so Databricks has the ability to scale, and it also integrates with a lot of other different offerings on Azure, including the databases, data lakes, and many of these other similar things. But the code that you bring to it is what makes it stand apart from something like Data Factory, which is more of a visual designer for building those kind of workflows. And of course, you can use a couple of things that I didn't mention here. You could use something like Azure Functions, but typically those don't scale real well under a batch style workload. So with something like a Data Factory or Synapse, you can bulk load the data and process it in bulk, while something like an Azure Function would struggle under that kind of workload. But you can still kind of do it if if your data sets aren't huge. And you can also use Azure Batch. Now, Azure Batch relies on the raw compute power and a VM that you install something on that will access data. And that's really up to you to configure all that. It doesn't provide connectors or any kind of built-in kind of as a service offering. It's more at the infrastructure as a service offering layer. And so that would be something that would depend on you to implement. And it's going to require a lot more work to get it up and running. But if that's something that you want to look at, that's certainly a offering that you can use to do batch style processing. And there are organizations that do that because their software won't fit into any one of these other kinds of categories. So between the hot path and the cold path is warm path, and it has some kind of functionality that might seem similar to hot path and something that might seem similar to cold path. And the real overlap of these two is more about the kind of tools that you can use for them, but the actual patterns look more like cold path. So the pattern in this case, it's still small batches of data, and so it's still batch oriented, but you can get away with using some of the kind of hot path tools that you might use for this. And now I did mention more tools that are more in line with what you would expect with cold path here, such as Data Lake, Data Factory, Synapse, Databricks, and so on. But you could also use something like Azure Functions. You can even use something like Stream Analytics or Kafka for some smaller workloads, depending on what those might be, through looking at just windows of data. So maybe you're looking at 5 minutes of data or 15 minutes of data, depending on what the data load looks like. So the distinction between hot path, warm path, and cold path really isn't clear. It's not like you can just draw a bright line between hot path and warm path and cold path. It's just like you can't between cold water and warm water, or warm water and hot water. It's kind of one of those discretionary things that's going to determine really what is considered warm path, cold path, or hot path. I just throw these up here to show you that there is kind of some different kinds of thinking that you can put into this whenever you're trying to build out your workloads. But the basic takeaway from this is that hot path is real time. Warm path is going to be more often smaller workloads that are going to be iterating on smaller time scales, say 5 minutes, 10 minutes, 15 minutes, an hour. And cold path is going to be larger data workloads that are going to be operating over long periods of time. It might be 5 minutes if there's a lot of data. It could be an hour, it could be a day, it could be a week. The discretion here is just really trying to figure out how you're going to be treating those and then choosing the appropriate tooling in whatever lane that you're going to be looking at here, be it hot path, warm path, or cold path. So the next thing that we look at is some kind of presentation of that data. Now we're looking at data that was collected by way of things that originated in the IoT layer. So it's going to be an aggregation of that data plus some enhancement of that data and some filtering of that data. So what gets presented here could be any number of things, but what this is intended for is for consumption, so that whatever's going to be downstream of this can look at the data in a way and make sense of it. So this is going to be things like APIs that are going to be consumed by applications. It's going to be reports that people are going to be looking at. Now that could be some kind of dashboard like report where you're looking at telemetry in real time or query telemetry out of a data set, or it could just be the raw data itself that you're going to be providing by way of some kind of data integration where you're taking some kind of export of the data and then taking that into another data system for consumption in that system. Regardless of whatever is the presentation of that data, it's basically the output of the data pipelines that you're employing either as hot path, warm path, or cold path. And the presentation then can take that data and then just make it available. So this is going to imply things like security, access controls, and those kinds of things. So there's a lot of things that you can use for data integration on Azure. Of course, there's going to be a database as a service offering. So anything that would store the data, so that would be SQL Server, Cosmos DB, MariaDB, Azure Data Explorer. There's a lot of different ways to present data there. And then you have the reporting services such as Power BI, which is kind of the one tool that a lot of folks love to use for building dashboards in the Microsoft context. And it can hook up to all kinds of data sources, and then it can import those and then use data sets that are manipulated inside of the Power BI context itself. And of course, you can use Azure Functions and Azure App Services for serving up APIs for that matter. So Azure Functions gives you the ability to create HTTP endpoints that can then query back into whatever database source that you want to use, or other data source. It doesn't have to be in a database. And then of course, Azure App Services, if you want to just write something like an MVC application that's going to be exposing some kind of data API, that external application then can consume from that data source. Now, over here on the far right, I have consumers. Now, this is not so much an explicit part of the system as it is a more implicit part of the system. The reason I bring it up is because ultimately what ends up in that presentation layer is going to be determined by what the external consumers of this data are going to want to be in that presentation layer. So whenever you're designing a system that is going to be presenting data in this way, you kind of start with the report or you start with the API in mind, and you kind of work backwards from that to the source data. And that's really why we have it set up this way. And the reason I include it is because you need to be cognizantly aware of how you want this data to show up in whatever is going to be integrated with it, whether it be a report, whether it be an API, or some kind of external data integration. Now, there is another thing that I have not mentioned up to this point, and it's because it's way over here on the left, back here on the things side of things, and it is the edge. Now, the edge in a IoT platform is what exists kind of on the edge of a network. That is, you have a local area network where you have a bunch of devices that are emitting telemetry and events and doing all those kinds of things that they do, and those are ultimately sent back to the cloud. However, in some cases, you might want to put some kind of preprocessor in place that will do some filtering and aggregation and some other enhancements on that data closer to where the devices are. So in a sense, the edge is almost a microcosm of everything that happens in the cloud. So you will have things like message buses, you'll have things like data pipelines and other kinds of data enhancement tools that exist in that context for the purpose of pre-processing that data before it goes over to the cloud side. And in many cases, it's going to be able to do a lot of the same kind of workloads in the same way that they get implemented on the cloud, just at a smaller scale and closer to the devices. So there's two services that are in this space on the edge that really shine, and one is the IoT Edge. Now, IoT Edge is a platform that you could put on the edge. It's more of an operating system that you can install on an appliance, and it's based around Docker containers. And you can do things like stream analytics in that context. It also gives you the ability to do message filtering and a number of other things that are a part of that ecosystem that you can build into whatever code that you want to make and install it by way of a Docker container on the IoT Edge. It also offers a message proxy for sending messages from devices to the cloud so that you can basically queue those messages up on the IoT Edge. And in the event of an internet outage, you can then queue those messages up there. And then when the internet is restored, it will then forward those onto the cloud. So it mitigates against things like losses of message. And there can also be some kind of local response to events in that particular context as well. So you can build in AI and other kind of event management into the IoT Edge so it can quickly respond to something like a fire, for instance. If a device reports that there's a fire, you can have a command issued by the IoT Edge to put that fire out, for instance. Databox is a similar service, but it's not as purpose built as IoT Edge. And it's basically bringing a lot more of the AI type workloads that you get in something like ML workspaces and that kind of thing, and bringing that closer to the edge as well. So it can do data ingestion and apply AI models in the context of an edge installation rather than having to ship all that data back up to the cloud. You can do it more intelligently on the edge and do it more quickly in many cases, so that you don't have to rely on an internet connection and the latency that the cloud introduces.
If you like this content, please consider visiting us online at www.wintellect.com, and there you can find about services that Wintellect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintellect on Twitter at WintellectNow or at Wintellect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintellect.com. Until next time, thank you.